Like we saw in the last video, it takes a lot of commands to get the containers up and running, even if it's just 2 or 3 containers. And really what we want is we want something that's going to be able to not only coordinate the activities of our containers and get the containers up and running, but even keep an eye on the containers. And if the containers have some kind of problem, go ahead and restart them, and otherwise make sure that the containers are healthy and responding to the users. So orchestrators can take care of this. They can help us build the containers if they need to be built, deploy the containers to get them running, and monitor those running containers to make sure that they stay responsive, or if not, tear them down and restart new containers from a fresh copy of the image. Docker Compose and Kubernetes are both container orchestration systems that have the ability to keep an eye on the containers. So over here we have a Docker Compose project, which itself is code. And so if we go into the folder that has this project, each of the services has a folder that has the code for that particular service inside. We have 5 of them. We have a database and an LDAP server. We also have database administration and LDAP administration servers, and we have web that's running the main application. So let's go ahead and take a look at the one that is the web. That's the most complicated in this project. Our code file is a Docker file, and this is where we're going to find the code that tells the orchestrator how to build the container if it needs to be built. So this itself is code, and it goes to the build engine. So we have a comment to start off, and then we have our base image where we start with the image PHP 8010, and then the lines of code start to run after that in order to create the container image. So we see some that will install the application and others that will go ahead and configure the application, configure Apache, install some software into PHP, and take care of the networking, exposing ports 80 and 443. Also in this project is the code that tells the orchestrator how to do all these functions like building the containers and running the containers. And that's in a Docker Compose file, since we're using the Docker Compose brand of orchestrator. Inside of this file is the instructions both on how to build the containers from the images, referring to the Docker files that were in those specific folders that we saw, and also how to run the containers. In this case, we have instructions on virtual networks that the containers need to be connected to, the ports that the containers need to be exposed on, any kind of volumes that need to connect real-life directories to the container directories, and so on. And so you can see how Docker Compose is able to not only build the containers if they haven't already been built, but when it runs them, it can coordinate them, connecting them together on these virtual networks and setting up the different networking ports that each individual container needs to run. And all this information is kept in a single convenient file. So the application itself is written from code, and then the container instructions, the Docker file, is code, and the Docker Compose instructions, the Docker Compose.yaml, is also code. Pretty much everything in the container world is code, whether it's code writing an application or code that's coordinating the infrastructure. To get Docker Compose to use this instruction file to get the containers going, we use the Docker Compose program, and we can say Docker Compose and just give it the simple instruction of up. We can run these containers detached, meaning run them in the background. if we want to as well. Docker Compose will automatically look in the current directory for a Docker Compose.yaml file, and of course there's one here. So it'll use that file that we just looked at. And one by one, it'll set up the networks. It'll check and see if the containers exist. If they don't, it'll use those Docker files to build them. And if they do exist, it'll go ahead and get them running on the networks prescribed with the ports that we set up. So now everything is running. Let's go ahead and open up a browser. If you recall, there was a database admin, a web server with an application, and an LDAP admin service, all three of which we can talk to. Then there were two background services. There was the actual database running in the background, and there was the LDAP server running in the background as well. We'll start with the website, and we browse to the website, and it'll tell us that the database hasn't been built yet. Of course, it's true because we're just now running it for the first time. So we'll click to set the database up, and once that gets running, then we'll be able to use the application. There's also going to be the php.admin server running. That's the database admin. And that one's running on port 81 per the configuration in the Docker Compose. And then the PHP LDAP admin server is going to be running on port 82, again, because that's the number we chose inside of the Docker Compose. Then when we're done working with the containers, it's just as easy to get Docker Compose to bring the containers back down again. We just use the Docker Compose program and tell it the down command. And again, it'll use the Docker Compose.yaml file to know what the names of those containers were so that it can go over to Docker and start to bring the containers back down. We click that command, and one by one, those services will be gracefully stopped and the containers themselves will be brought down. And if we want to start it back up again, it's easy enough to use Docker Compose to bring it back up. So we can see how an orchestrator can really make starting and stopping the containers a whole lot easier. Otherwise, we would have had to have typed out 5 individual commands to bring those containers up, plus other commands to set up the network. And then we would have had to have used 5 more commands to bring the containers down, and then more commands to bring down the virtual networks. So using a orchestrator makes all of this a lot easier. There are more advanced orchestrators than Docker Compose, like Kubernetes, which has the ability to do all these types of things, but it can do them at scale more easily than you might otherwise be able to do. There are competitors of Kubernetes, like you can use Docker Swarms, which is a similar idea where you're scaling the orchestration of containers across different virtual machines, where you're not only controlling all of those containers that are running on that VM, but you're even doing that activity across multiple VMs at the same time, and again, keeping everything coordinated.